Yeah, so my name is Manoradh, and I'll be talking about enterprise AI with IBM DB2. So joining me is Mr. Sivakumar. He'll be joining us through Zoom. So I'll be talking about enterprise AI, and he'll show us how he'll show us a demo on how to connect the database, and he'll run a model for us. So yeah. So I'll be giving you a basic insight of what enterprise AI is, and I'll be giving you a basic insight about IBM's DB2. I will take you through the ML capabilities in IBM DB2. So before we get into DB2, we'll see why we're talking about ML, which is a part of DB2. Now, as you can see, 66% of the ML projects use relational data from enterprises, that is business organizations. So this survey was conducted from by a data science community in 2017. So you can imagine the number only going up, because as the use case of ML has only gone up in the past few years. Like now from this number, we can see that it means that most of the data is from business organizations. So we have a lot of opportunities to partnership as a database product with enterprises and their data science teams to work in machine learning environments. Now, before talking about IBM's DB2, let us have a brief look at what artificial intelligence is. Like you all, yeah. So you all basically know what AI is, right? AI can amplify human capabilities and understanding. So this helps us in transforming huge data collections into huge data collections that are only growing bigger and bigger all the time into values, insights and actions, if I may say so. So if, for example, if I'm going to create a system, if I'm going to create systems which can identify objects or human language or speech, all these would come under AI. They would come under artificial intelligence. And the next question is, how are these systems created? For that, we have two approaches. One is machine learning and the other is deep learning. So with the help of these algorithms, and data that we provide to the system, it helps the system to learn more about the data and work accordingly. So if we're working with regular mathematical or scientific algorithms, we could use machine learning. If we're working with how the human brain works, if we're working with neural networks, we can use the deep learning approach. So yeah, that is the basic outline of AI, ML, and deep learning. Now, sorry. Yeah. So this picture is the typical workflow of a machine learning environment in development enterprises. As you can see, the flow starts from the data pipeline, and it is the responsibility of the data scientist to take his sample data from the data repository and put it in a system development environment. So yeah. So once that is done, like once you put it in the data development system, he can do all his data cleaning and training processes. And after cleaning the data and after the training is done, you get the structured data. And structured data is, classified into two categories. One of that is training and testing. So then the data scientists can use different data processing steps like hyperparameter tuning, future engineering, and PCGs, and they'll try different algorithms on it and will come out with the exact model for their workflow. So this whole process is the model development phase of the machine learning environment, and yeah, after this comes the deployment phase. So when we're working with the development phase, we face a few challenges. Let's have a look at what the challenges are. So the first challenge is regulated data. Now, regulated data is nothing but sensitive data. So like you need to be very careful when you're handling sensitive data. They are under regulations like GDPR, CPRA, etc. So if you're going to copy this data for your work, we should be very cautious about its confidentiality. The next challenge is data volume. In general use cases, when we are learning or when we're trying to do some regular process, you'll be using data in gigabytes. But this isn't a really big data. When you're working in real life environments, we'll be working with a lot of data, like hundreds and hundreds of terabytes of data. So this is another challenge for a regular computer scientist on how he's going to deal with large volumes of data with the limited resources he has for his data model building. Now, the next challenge we face, the third challenge, is noisy data. Noisy data, as we know, consists a lot of unnecessary, unwanted information, and obviously using a lot of all this unnecessary information is going to depreciate the quality of our products. Yeah. So, yeah, once we are done with the development phase, and once we've handled the challenges of development, we're going to talk about the deployment flow. So at some point, once we've handled all the challenges in the development stage, we have a decent model with good accuracy. So now we'll try to deploy the models. Now we're going to see the next set of challenges in the deployment stage. This is where we're going to integrate a model for user functionality. So the first problem, the first challenge in the deployment stage is hosting. That is where we're going to host our model for user consumption. And the second one is, the second is speed. Suppose my data is in one location and my model is in another location. Every time an insurance is done, for example, I'd have to, my data has to be taken from the database to my model, to the location of my model, and you then get my prediction. So this could create a network latency, which is undesirable. And the third problem is integration. It's how you're going to integrate your model for easy prediction. So yeah, that is about the challenges in the deployment phase. So now, how can IBM DB2 help data scientists in addressing all these challenges? So IBM DB2 works on the philosophy of in-database machine learning. What this means is it keeps the code near the data to reduce latency. It is, as we know, it is necessary to keep the latency low. So IBM DB2 includes a wide range of in-database SQL analytics. So that includes some basic ML functionality too, and also it has in-database support for languages like R and Python. So yeah, this is why we're concentrating more on DB2. And yeah, these are the use cases for in-database scoring. And the first one is latency-sensitive decisions. If I'm going to, let's suppose if I'm going to create a model for payment processing or fraud detection, like when you work with payment processing, people use cards, right? When you access the card, you check if the data is right. When a person swipes the card and you access the card to check if the data is right, or if there's any fraud that's taking place. When a person swipes his card, yeah, the data has to pass through the ML model. It has to be checked, and the result should pop up as soon as possible. So the data should be latency sensitive. It should be quick. And the second use case is large batch prediction. So if you're going to work with large data, suppose we have to come across several set of analysis, like we are working with anomaly detection, for example. So moving data across across another system, every time you get a prediction is very expensive and leads to slow process. So yeah, so this kind of use cases will be benefiting from IBM's DB2 databases. And yeah, so now I'll give you an insight of how IBM DB2 helps a data science practitioner in addressing the above challenges in development and deployment stages to get a better solution. So how we're going to address how DB2 addresses the challenges we just discussed. So in this, we'll be learning about the two different solutions for the challenges above. And the first is to integrate the open source models with DB2. As you can see, we have several open source frameworks. If you all are familiar with ML and deep learning, you'll be familiar with open source frameworks such as sklearn, PyTorch, TensorFlow, Keras, etc. And these frameworks have rich ecosystems to build machine learning models. The second is building your entire ML pipeline inside the database, inside DB2. We have frameworks given by the IBM DB2 for using which we can build models inside it. And yeah, these two are the approaches that you'll be going to build an AI lifecycle using DB2. So let's talk about the first solution. When you use open source models, when you bring your open source models to DB2. So when you talk about, when you talk about open source models, IBM DB2 has a solution called the Python UDF, that is a user-defined function. If you're going to work with open source frameworks like the IBM Watson or the Jupyter, Jupyter Notebook or TensorFlow, you'll be using these libraries inside the framework and will be developing a machine learning pipeline. Now, this machine learning file will be saved as an executable file with the help of a joblib. And so what Python UDF does is it pushes the joblib into the database, into the DB2 server by using user-defined functions. So with the help of UDFs, you can do inferencing inside your databases, inside your database. Sorry. Yeah. So how is this inference in your database server? So you have the client application and the inference request, so which will be sent into the database using SQL statement. There you have your model file, which has the trained model, and your data. So you have the model executable file, which will help you, to get your predictions inside of the DB2 server. And yeah, the benefits of this is the presence of the ML infrastructure. There is low latency because taking your data outside and inferencing it and putting the data back inside will increase the latency. And yeah, working with Python UDF, you have low latency, high throughput, and yeah, simpler integration. Now, the second solution is building and deploying models inside DB2. Now, yeah, so IBM DB2 has released this version 11.5.4 with all ML capabilities. So if you want to do data exploration, you can you can do summary statistics, virtualized data frame, feature selection, and data frame operations. If you want to do pre-processing operations on your data, you can you have missing values, you can do normalization, standardization, discretization, and training test split. Now, if you want to train the model, you have algorithms like decision trees, naive Bayes, linear regression, and k-means clustering. And after you're done with exploring your model, pre-processing the data, and training your model, when you want to evaluate your model, you can use confusion matrix, accuracy, precision, recall, and if you're working on linear regression, you can use MSE and MAE. And after all this, after evaluating your model, when you want to deploy it, as we discussed, we have two approaches to it. That is in DB2 prediction, and or we could use Python user-defined functions. I'm sorry?
How do you use these features?
Yeah, that my partner, Mr. Shiva, he'll be explaining on that. We'll be. I'm just giving you the basic outline, and then he'll be explaining how to connect the database. How do you connect to the database? He'll run a model, and he'll give you a brief an explanation. So basically, these are the challenges we face with regular ML models and the benefits of using DB2s. So yeah, we have data transfer costs while we use regular ML models, whereas in DB2 there's no data transfer. And yeah, infrastructure is a big problem when you are using regular ML models, but DB2 is secure and scalable. Yeah, that's about it. And yeah, so Mr. Shiva will be taking on from here. If you could just.
Okay.
Can you hear him?
Yeah. Hey, Manoradh, can I share my screen?
Yes, please, Mr. Shiva. One second, just give me a second.
Cool.
Yeah, I think you can.
Okay.
Yeah, I think you can share the screen now.
All right. Where's the screen? Okay. Do you see my screen?
Yeah, it's visible. You
Okay.
can go.
All right. Hello. Hey, good afternoon, everyone. My name is Sivakumar. I work for Werner Enterprises, one of the largest carrier in Midwest America. And first of all, thanks, Manoradh. Thanks for giving a great introduction on AI platform, and which is so exciting. And again, I apologize for not being there. I was supposed to be there to give a direct demo and talking, but because of some logistic issue, I couldn't be there. And thanks, and again, a couple of thanks to Mr. Ganesh and Dr. Samir for giving this opportunity to set up this AI platform in University of Oregon and run through this demo process. And thank you so much. All right. So let me just cover quickly. Werner, we are kind of largest one of the largest carrier in Midwest America, and we have like our company started in way back in 1950, and with one truck. And today we have like almost 8,500 trucks and 35,000 trailers, and we are like a $2 billion annual turnover company. And you might have seen like blue trucks around, and that's we trucks. And we basically operate in North America, Canada, and US and Mexico as well. All right. So just coming to that the process. Which Manoradh he gave two scenarios. One is open source, connect through EDF functions to connect to DB2, and using Python and Python job-lib, how you connect database and do the machine learning process. So what I'm going to show you is I'm going to show you a demo as well as a process how we are utilizing that in-memory database learning, right? So in this case, what we are doing is we are utilizing the DB2 stored procedures, which comes with DB2 to build the entire machine learning process. So this setup right now, this setup is running on University of Oregon in one of the Linux server. And the idea is we set up a DB2 11.5 fixed-pack 5 environment on Linux. And here is how we set up. Basically, we enable the ML procedures capability for DB2, and we set up the database, and we initiated the insys install object. Basically, we set up that machine learning module, which is a set of IDAX stored procedures, and also a separate table space for holding those machine learning tables in the database. So this is a setup. So I'll just quickly cover, just to add what Manoradh said. So we have different modules, right? So there are various modules comes with this machine learning. So first, the step two if you're going through a step two process, step two is exploring the data. So we have a IDAX summary 1000, that is a store procedures we are utilizing. And a data transformation, in this case, we are using a IDAX split data. So using the split data, you are making a train and test data, right? I mean, based on the input data set. So you're splitting data into a training and a test data. And also, we have. I'm not going to cover all the procedures. I'm just going to cover in this demo. I'm going to whatever the highlighter procedures. That's what I'm going to cover. And for model building, again, we have grow deck tree, linear regression, naive Bayes, and k-means. These are the kind of 4 models comes directly with DB2. So I'm going to cover naive Bayes, and that doesn't, you can use k-means and linear regression and grow tree based on your requirement. And again, if anything outside these models and your data set needs to be do modeling, then that's where we can use the Python code, right? Using Python code, you can build your own algorithm, and then you can call through a job lib, and then you can, using UDF, you can work with DB2, right? So this is a given algorithm coming directly from my DB2. And for model evaluation, we are going to use the confusion matrix to see how that our test data, what are the test data we feed, how that is matching with that trained data set, or how it is closely matching with what we predicted. And for model inference, we are going to use predict naive Bayes. So that's basically predicting the data set based on the incoming data, how the data is going to be predicted based on the model what we built. So this is what we're going to use. But what I'm showing others are, you can use predict deck tree and k-means, the clustering algorithm, as well as linear regression if you are using that, you build the respective model using those algorithms. All right, so this is a sample, the test bed what we are focusing is. So what I'm showing is a truck, right? Our trucks are going in on the highways, and our trucks are set up with so many sensor unit, right? So our idea is capture those the engine, all the engine data from truck's engine, as well as battery, as well as tire, right? All this data get fed directly through a Qualcomm unit. We have all the trucks comes with that Qualcomm. So we're capturing the data set and feeding into a DB2 11.5.6, sorry, in this case 5 database. And our idea is we build that based on the maintenance data set. We are going to build a model, and once the model is built with the new data set incoming data set, our idea is telling that, based on this data, does the truck need a maintenance, right? And alert the driver so that he can quickly take the truck to a maintenance location and perform the maintenance accordingly. And the idea is which will prevent costly accidents, and also we can tell our customers to get the trip in the right time, right? We can, in case of there is a delay, we can always alert the customers accordingly. So the first phase is collecting data. So we use data replication. So data replication is moving data from Qualcomm to our DB2 11.5 database to continuous feed from the engine. And if you look at the data set, this is the kind of data set we performed. Don't worry about, we use so many features. So usually we use tend to, based on naive Bayes algorithm, we use not more than 10 feature, but in this case, I used most of the features, what we had data set. This is just for testing purpose. So what you see is the temperature, vehicle speed sensor, and vibration, engine load, etc., right, coming directly from our engine. And with all this data set, what we labeled is the label column. What you see is a maintenance flag, right? So that's a flag. So our idea is, based on this data set, if the truck needs a maintenance, and we want to predict accordingly. This is basically I'm just doing exploring the data set. So let's start from table, and this is a sample data set I'm showing in the screen. And last column is the maintenance flag, which is the label, right? Label for this analysis. Okay. So if you look at this picture, what we did is we took the data and we fed the data into a in table. That is a free naive Bayes naive Bayes table. And using a summary, this is how we do the machine learning. So you just look at that, calling that store procedures and feeding the input table. It basically shows how much data, right? In the what kind of data we have, and explore, and you can do so many things with this summary 1000. And calling the IDAX split data, we basically split the data into two data sets using using the split procedure. And one is train, and another is test. And then if you look at that fraction, which is 0.95, so 95% of the data go into a train data set, and then 5% go to test data set. And using that model, for the model building, we use the naive Bayes, as I said, it's going to be yes or no. So I used a naive Bayes model, and using that model, using the data set, I trained the data set with the 95% data. And we built that model, right? Fleet naive Bayes model called Fleet naive Bayes. Then we can print the model, just to show the model how it is, how it looks, and then that's how we print it. And then next is the predict, right? So now that we build the model, so we want to send the test data into the model and see how much data we can closely predict based on that the model what we built. And this is the exact procedure. And then we build the confusion matrix. Basically, it will tell us with the test data with which is already predicted, and what exactly predicted through the which is already labeled. I'm sorry, which is already labeled, and which is already. And then what we do is we ran this model from the model output, compare the data set, and show that how the data looks like. So in this scenario, in the test, I will quickly show you a demo. But before that, in this data set, what I'm showing is out of 375 rows, that incoming test data, we found that only 61 records were different because it didn't predict accordingly, which is nothing but 16% difference. So this model, what we built, is like a 84% accuracy. And then again, we need to feed more data set into this, again, collect more data, correct it, and then make the label, accordingly. And then we need to rerun the model accordingly. So, I mean, this is just an example. I'm showing how a model is built, and I'm showing the percentage difference. So let me quickly jump to the demo. So what I'm showing, any questions so far? Do you guys see my screen now? There's a putty screen. Do you see my screen?
Yes.
Okay, got it. All right. So what this is server is, this is the University of Oregon. It's called the Vina server, one of the Linux server. DB2 is running on DB2. So what I'm showing you 3 screens here. One is showing my processor, right? CPU on the left, the top corner, leftmost top corner. And then the bottom one is that this one is the DB2 logs. I mean, I'm doing the logs, how that's what happens when I'm running the machine learning process. And then what the right side, this is the main screen I'm showing. These are all connecting to the same server and same database, right? So first thing is I'll show you. This is the version. So the DB2 here, what we're running is DB2 11.5.5. That's a DB2 version running on the server. And we set up a, this is my, so this is my, I have 2 databases. One is a test DB and then SLPDE. And these 2 databases are enabled for machine learning right now, right? So what my machine learning is going to be run against the test database. That's where I set up all the procedures and the data set, right? So if I'm going to, right now I'm going to run the data set, machine learning process. Okay, so this is the script developed. So what the script does is it's going to call step by step, right? Taking the data set and explore the data, and then split the data into test and train table, and then build the model, and then prediction, and then build the confusion matrix, right? So I'll show you. I'm going to run this right now. And again, apologies, the process may take a little longer because we are running on a Linux environment, and which less resource. And I will explain our future process, what we are planning to do in improve the performance and stuff. So I'm going to run this. So basically it connected to the database. And if you see the left side, that's the logs are moving, right? It's running, the process is running. So right now what I did is so far, and the top, what you see in the top screen is the disk IO and the CPU performance right now. And the CPU is spiking, and my process is running now. And then see, I already split the data into 2 data set with the 95% go to the train data. And here I'm right now building the model, right? Fleet naive-based model with the incoming train data set. And my CPU is spiking. And so this process takes a couple of minutes. And so let's see. I mean, once this process finished, so we have the model built from the train data set, and then we can do some prediction out of it.
Is the model running on the DB2 server or mine?
This is running directly on the DB2 server, right? Is it? What is the question again? I can't hear.
Is the training running on the DB2 server?
Yeah, exactly. Yeah, we train data set directly running on the, we set up on that DB2 server. So if you look at the top, this is the input table, right? This is the main table. Okay, I think I'll show you. I think it's already ran. So if you look at this data, this is the input table, right? The main data set coming from the in table. So I split the data into 2 tables. One is fleet naive-based train, and then a fleet naive-based. Okay. So my process finished. So I will quickly explain what happened here, and then you can ask me questions. So first I explored the data set, right? Naive-based table. There are like 7,504 records are there. And so, okay, sorry. I dropped all this I cleaned up the data set. Here I split the data. So the input table is naive-based, and I split the data into a naive-based train and then a naive-based test. These 2 tables are going to create on the same server, right? Same database. And once it split the data is done, I'm showing the data, right? Out of 7,129, out of 7,500 rows, that's the main table. I split 95% data, go to the train data table, which is 7,129. And then remaining 5% data go into a test table, right? This is the test table. I'm doing a count here. Then I call the naive-based model with, this is the naive-based model I'm going to build, just a name. And I'm going to call this, this is the DB2 provided store, the store procedure. So for that, I input the model name and train, I'm going to use the train data set, right? I'm going to pass the 95% data into here. And then target is my maintenance flag, which I showed in the input data. And then these are the 2 variables I need to pass, the bins and binaries and disk. So once the model, this is the main core brain for this setup. Now, once the model is built, and this is the, basically I'm printing the model. The model size is, this is the model size. I'm printing the model. And this is just, internal to the, how the model is performed. And once the model is built, I'm here. This is what I'm calling the predictive naive-based. This is again DB2 inbuilt store procedure. So the same model what I built, I'm going to pass the test data set now, right? Because for which even though I have a label, I'm not going to use the label, and I'm going to predict. Tell me how many records are matching with what I already have the information. So when I pass this test data set, so the number of records are, as I said, 375 records. So for this, the result set, for this result set, I performed the result. And when I ran through these are the join between some joins between the naive-based and then results data table. And then I go to build the confusion matrix, right? Once I build the confusion matrix, so this is what I'm showing up. Out of 375 records, what I passed, there are like, in this case, 59 records didn't match. So which tells me like a 15%. So the model is 85% accuracy now, right? So my confusion matrix this is the confusion matrix. So basically this is good, right? Out of 375 records, 242 0 and 0, which is the maintenance flags not triggered, which is matched, and 1 and 1, which is 74 records matched, and this is 59 records didn't match this count, right? Because of my model is not, again, no model will be like 100% accuracy, but in this case, my model is performing like 85% accuracy. So this is the confusion matrix. I can take questions, but before that, I just want to cover a couple of things. So this is just a demo, and again, we are running this on a Linux server, and I will. This is all my demo completed, and before closing, I want to give a couple of things. Let me share my other screen. Okay. All right. So the demo completed, and here, right? I mean, do you guys see my PowerPoint screen?
Yes.
Okay, got it. So with this predictive modeling, right, what we built for maintenance, truck maintenance. So more focus is, some more focus we are focusing on. So with it, with the data what we have, we can accurately predict how long my truck can run, without maintenance. So once I start my truck, and until I get my indicator, right, the maintenance flag indicator, I can know how long the truck is going to run without maintenance. And again, these are some more we are kind of focusing, like using the driver data set. We can perform like because we hire like 11,000. We have 11,000 drivers at any given time, and we want to know how many drivers can quit in the next 30 days. So we have a come off using a driver demographic data set. We can quickly analyze and then find out how many drivers can quit in the next 30 days. Because every day we hire like 300 to 400 drivers, right? We have large turnovers, and using the data set, we can accurately predict the drivers. And then our company turnover, we can, based on the financial data set, we can predict accurately how much we're going to make in next 5 years, 10 years kind of thing. Again, the accident prevention, yeah, that's exactly what we are using this maintenance data set to prevent accidents, right? So accident is very, very costly for us. I mean, if one truck involved with the accident, we spend like millions and millions of dollars, right? I mean, I mean, this maintenance information helps us to prevent costly accidents. And battery life, again, these are like a battery life, truck tread wear, right? I mean, the tire tread wear. So those are kind of coming with the maintenance information. So again, we are capturing those data set and alert drivers accordingly to go and change your tire or change your battery before getting stuck in one place on the roadside. And also for the drivers, we want to alert the drivers with the weather, right? I mean, drivers will be operating in different locations, different part of years, and then in case of any bad weather, or like a tornado or a hailstorm or a hurricane, who knows? I mean, again, this weather they can find out from their gadgets, but our idea is we want to track the weather and immediately alert. We have all our trucks are fitted with the Edge Connect, which is a mobile app. So we want, if there is any forecasting, right? Hey, there's a hailstorm or there's a tornado or something coming along the road, we want to alert the driver. So accurately predict where the truck is located and capture those weather information, and we want to run through K-means. Like that's basically unsupervised learning process, and we want to capture those weather information and alert the drivers accordingly. So a lot of things happening in the logistic environment. And jumping onto that performance, right now we are, as you said, the machine learning, again, IBM's machine learning process, as Manoradh was showing, it's running on only on Linux, right? Linux environment and Linux environments. So we want to utilize that power server, the AIX power server. And one thought is right now, our Dr. Samir is helping us to set up a AIX server on University of Oregon. We are in the process of setting up, and we have some open issues with the LDAP connection. But our thought is, if you have a Power 9, and again, IBM is coming with the Power 10 processor, we want to utilize that chip, right, for running that machine learning in that large data set. So one of the thought is we are planning to build an OpenShift environment, on the AX platform and test the same machine learning process and see how quickly that runs the process. So I mean, again, I'm a DBA running for working for last 21 years with IBM and DB2. And we have a large data warehouse, right? I mean, our data warehouse is very large, and most of our data warehouse is running on the AX platform. And if IBM, again, I'm not sure IBM's focus, what is the future focus, and if they're able to help us in running the machine learning process on AX server, that will be great. But otherwise, if it is at all, we need to go through Linux, then eventually we need to set up this OpenShift and run that machine learning process on the OpenShift container, so that we can predict the process. So this testing process, and hopefully we'll be completing this test in the next month or so, once that AIX server is ready with that OpenShift environment. Right, then I think that's all I have. And if you have any QA questions, please bring it up. And here I'm putting both my partner Manoradh and my email addresses. You can reach to us with any specific questions, and we are happy to assist. And also you can touch base with Ganeshan and Dr. Samir for any open questions. Thank you so much.
Mr. Siva, they have a few questions. Can you hear me?
Yeah, I can hear you. Yeah.
This is Manoradh. Would you be willing to do a reference to the DB2 team themselves? I work with them very closely. They love to have to say.
Okay, sorry guys, I'm getting a lot of echo. Can you, or Manoradh, can you just repeat the question, or can you keep the microphone close to the audience?
Sure, I can repeat that question actually.
Okay.
Matt is asking, do you want to give a demo to a DB2 team about this? We have done this already, right? The Toronto team. We have done this. We work with the Sheikh Khalid.
Okay.
Yeah, exactly. Yeah.
If you have anyone else also?
No, I'm working with the DB2 team on data warehousing, and this is really interesting.
Oh, yes, sure. We will connect. Sure.
Okay. Yeah. We can connect to you. And so your data warehouse running on a AX platform, right?
Both AX and Linux.
AX and Linux. Okay, perfect. So if you're on Linux, then you are all set. So only thing is, as long as you're running on, if you're running on 11.5.4, you should be good. But if you're running on anything less than 11.5.4, you need to upgrade your database to 5.4 to utilize this machine learning process.
Okay.
Yeah. So in fact, we recently upgraded our AX platform to ours was running on 11.1. And the last month, we upgraded our database to 11.5.4, and we are kind of utilizing some of the machine learning process. But again, you need to make sure you are upgrading 11.5.4. Also, you need to run. You should be running on the Linux environment, right? Linux. That's where the machine learning supports right now. Until IBM comes with a power server, or another option is, as I said, you can create a OpenShift environment on the AIX, and you can run that machine learning there. Does that help?
So I think that's it for the talk. Thank you so much, Mr. Shiva, for joining us.
Okay.
We have another question. We have one last question.
Okay.
If you could please come here, I think. Yeah.
How does data processing take part?
If you could come here and. Sorry.
Sorry, sir.
Yeah.
How does data preprocessing take part in DB2?
Okay, that's a very good question, sir. Yeah. So as I showed you, the data pre-processing, right? I can show you. Okay. Okay. So you see this the data transformation process, right?
Yeah.
So once the data is sitting in a table, right? Your data warehouse or data table, you can utilize IBM. These are the set of stored procedures delivered once you build that once you enable that machine learning. So we have impute data, imputing missing data, or again, I showed you a split data just to transfer the data set, incoming data set, into two different tables. But again, you can use a standard norm and EF disk and discretization and applied disk. So these are the kind of procedures. Along with this, if you already have any tools like a data stage, ETL tools, you can use that ETL quality stage tools to do the data massaging and data cleansing, right? So the pre-processing, data cleansing, you all can do with the existing the tools you have, but again, machine learning is providing these kind of additional functions, procedures. You can utilize them to processing and pre-processing the data set.
Okay, thank you, sir.
Yeah. So thank you. And see, our whole idea is we don't need to transfer the data anywhere, right? With the as Manoradh was showing, there are so many steps we need to go through, and here we are not moving the data to anywhere. We're just keeping the data in my database, and I'm quickly using this given store procedures. I'm doing the predictive analysis. That's the beauty about IBM. And again, I am a DBA. I'm a DB2 DBA for 20 years. I'm not into machine learning, but this helped me when IBM released 11.5. When these procedures came in, I was so fantastic. I mean, surprised, and I spent more time in understanding those procedures. And now, as a DBA, I can do machine learning. I can switch to machine learning process, and I can build this predictive analysis within my database. So that's all about.
I think that's it for the questions. Thank you, Mr. Shiva. Thank you for joining us.
Okay.
Yeah. Thank you, everybody.
All right. Thanks a lot, folks. Thank you. Thanks, Ganesh and Dr. Samir.
Thank you. Interest of timing, let's skip the break.